Hi students, welcome on the channel. So in today's video, we are going to talk about this conservative and non-conservative forces, and we will particularly look at the application of the curl to find out and to categorize that whether it is a conservative field or it is a non-conservative field. So I will start with the introduction to the conservative and non-conservative. There is one more video on this channel. I will attach the link that just theoretically defines what is the difference between the conservative and the non-conservative. You can also go through that, and there are the other videos related to the differentiation and the other chapters. You can watch all other videos to know more in depth about the physics. Okay, so let's start with this conservative. So to understand these conservative and non-conservative, I'm taking the example, two examples I'm taking. For the conservative, the example I can take of for the conservative, I can take the example of the gravitational force or the gravitational field. Right. See, in the 11th class, you might not be knowing about this field. Okay, so field is something like the force only, like we have the gravitational field or the gravity. You must have heard about that. So just multiply with the mass, which is a constant, and then you will get a gravitational force. So that you will discuss in the gravitation. This topic is related to the work energy part. So if you are a 11th student, you may not know about the field, so that is okay, there is no problem. Field, you can just treat it as a force right now. Okay, and if you are a 12th student, so of course you have the idea of the field and you have a somewhat conceptual understanding and a picture in your mind to understand that. Okay, so this is one example, and the another is I'm taking the example of magnetic field or the magnetic force. So I will come to this why I'm taking this two examples, field or otherwise you take the force. So let's do a experiment and let's try to find out what will happen in the gravitational force. So let's suppose you are on the ground on the earth, and then you throw a ball or a coin in the upward direction with certain velocity in the ideal conditions. Okay, so when I say ideal condition, it means no other force than the gravity. So if we throw with v velocity or u velocity in the upward direction, then it is going to go up. Okay, then it will return back on the ground. Tell me what will be the velocity when it will return back. From the kinematics also we know, or otherwise Newton's laws of motion you can apply, and then you can find out that the velocity while it is returning is also, or the speed is also u. So if you go at the work energy theorem, work done by all the forces is equals to change in kinetic energy. Sorry, it is not a vector quantity. So that is equals to change in kinetic energy, because the speed is same, so that's why the kinetic energy is not going to change. So what you can say, work done by the gravity is zero. Quite simple to understand. You could have said that with the help of the w equals to f vector dot s vector, while it is moving in the upward direction, force because of the gravity is in downward direction, so that's why when it is going up, the work done is negative, and when it reaches the up and then it is coming down, the work done is positive. So let's suppose while it is going up, the work done is w1, while it is coming down, the work done is w2. So then I can say the sum of these work done in a closed path is equals to 0. Closed path means the beginning point and the final point is same. So in that case, if you take all the work done in the complete process, the sum will be equals to 0. This is one category of the force or one category of the field. Okay. The other hand, we have the other category, the magnetic field, for example. So like if you take so for that you should also have some idea about the magnetic field. So let me just introduce you to the magnetic field if you do not know. So like for example, if you take the bar magnet, so in the bar magnet we have two poles, that is Everyone knows that. Okay, we have north pole and the south pole, and the field lines will come out from the north, will go to the south like this, and inside the magnet they will travel like this. Okay, so of course you may get doubt, okay, how do you know that inside the magnet they start from the south and they go to the north? Now that is on you to understand. Okay, you try to find out. Now there is, again, you can draw a lot of lines. Okay, just note one line, there will be another line. This, all these things you will study in the 12th. If you are a 11th student, do not worry about that. Okay, then one more field lines you must have studied is like this. Like for example, if I take a wire, a straight wire, and a current is flowing like this, then the induced magnetic field lines. Okay, that also is a part of our 12th. So the magnetic field lines will be like this. You may have done that experiment where you put this magnetic material powder on the paper, and there is a wire and the current is passing through that. Then this magnetic material will arrange like that all around this. So from there we get the idea that the magnetic field lines are like that. Okay, now think about it, that we have theoretically, okay, we have a pole, a magnetic pole, whether it is north pole is south pole. So if it is placed on this, so then it will experience a force. Okay, so of course the force will be equals to whatever the magnetic pole is there. Okay, let's suppose that is q times of whatever the field is there. Okay, that much force it will experience, and then it will move like this, and when it will complete one circle, of course it will gain some velocity. Of course it will gain some velocity. Okay, and now if you say the work done in a closed path, that comes out to be non-zero. All right, so what is happening here? If you look, if we take the conservative forces are those kind of forces where the work done in a closed path is zero. Quite simple to understand. It is a very basic definition I'm giving. And then we have the non-conservative forces. On the other hand, for them the work done in a closed path is non-zero. Okay, and one more thing we can say, that the work done is independent of the path in this case, and here it is dependent, that you will understand. Okay, now let's come on to this. Okay, we wanted to discuss about the skull specifically. Okay, now like we have gradient, like we have this whatever, like we calculate the slope, we calculate the differentiation, we calculate the integration. So these are mathematical tools which have also some physical significance. Like for example, if I talk about the differentiation, what is the physical significance of the differentiation? It gives us the rate of change, right? Gradient also is something like that only. It gives us the rate of change of one quantity with respect to another quantity, like we have the velocity gradient. Okay, and likewise there is a mathematical operator called as skull, right? So what is skull? What is the physical significance of the skull is that it tells about the rotation of the field. Okay, what is the meaning of that? You know about the rotation, it means moving in a circular something. Okay, so like for example, if I take this magnetic field, so magnetic field, if you draw on picture on a plain paper like this, so it is going to be a closed path like that. Okay, it will be something like that. So it will be forming a closed path like that. But on the other hand, if you take the gravitational field or electrostatic field, for that matter, let's suppose you have the positive charge, so then in that case the electrostatic field lines are going to go outside like that. Okay, now in case of the magnetic field lines, if you take the magnetic field lines, they are forming the closed path, so they would of course rotate, they will rotate. And in case of the, if I take the electric field lines or the gravitational field lines, okay, they will not be forming the closed path. So curl is a kind of operator which will tell about any kind of, like, whether if you take electrostatic field, or if you take gravitational field, or you take magnetic field, or any other kind of field. If you apply this operator, and then if you calculate the value, if it is the rotational, so then it will give the curl, the amount, how much it is rotating. If it is not a rotational field, then the curl of that field will be zero. Okay, understand it. What is happening? Curl is a operator which is telling about the rotation, and if it is irrotational, if any kind of field is irrotational, in that case the curl of that field will be equals to 0. Why? Because it is irrotational, it is not rotating, and this whatever the operator is there, that tells us about the rotation, and if it is rotating, if it is forming a closed path, then only it will be non-zero. So in case of the rotational fields, in case of the rotational fields, I can say that the curl of the field will be equals to 0. Now you might ask, okay sir, how do we mathematically come to know that this operator only tells about the rotation? So that is like a bit advanced to understand. Okay, of course there is derivation for that as well to understand, and we can also graphically and geometrically we can understand that how this curl operator tells us about the rotation, but that goes very out of our syllabus, so I'm not going to discuss about that. And if you want to learn about that, you can search somewhere. And even if you come to this curl, this is rarely used concept, but still I'm explaining this. Okay, so in case of this, it will be non-zero in case of the rotational fields or the forces, right? So now in case when they are irrotational, of course the work done in the closed path will be 0, right? If they are rotational, then the work done in a closed path will not be 0. So what I can say, that the rotational fields are basically conservative fields, non-conservative fields, and irrotational fields are basically conservative field. So that's why mathematically now I can say, what I can say, that the conservative, if there is a field which is a conservative field, or a force which is a conservative force, then the curl of that force will be equals to 0, delta cross F. Okay, this is how we write down, and that will be equals to 0. Now how do we mathematically calculate this? So this will be expanded. Let's suppose you have f vector, and f vector in the Cartesian coordinate system is given to you as fxik plus fyjk plus fzkk. Okay, there are 3 components. So in that case, if you calculate curl f, so then this is how you are going to calculate it. Sometime we will also write it like this, curl f. Okay, sometime it is also written like this, rot f. That is same thing. Okay, so that is d by dx. Okay, okay, first we'll have I cap, j cap, and k cap. Okay, then we'll have dou by dou x, dou by dou y, and dou by dou z. Then we'll have fx, fy, and fz. This is a matrix. You calculate the determinant of that, and then you will be able to find out curl f. And if that is equals to 0, so then that is a conservative field. Okay, so let's understand like how you will do here. So you will take I. When you take this I, so then the first row, first column you will not use, and then you will write it as dou by dou y of fz minus dou by dou z of fy. Okay, then minus j cap, and then you will say dou by dou x of fz minus dou by dou z of fx. Then you will have plus k cap, so dou by dou x of fy minus dou by dou y of fx. Okay, so like this you will have, and then you can calculate, and if it is equals to 0, so then that is a conservative field. Okay, so hope you understood this. Let's take one example to understand this one, that how you are going to find out. Let's suppose you have been given a field or a force, you need to identify whether it is conservative or not. So the force vector is given to you in the component form. XYZ components are given as 2xy x component, y component is x square plus 2y z cube, and the z component is 3y square z square plus 2z. Okay, so these are components. So now we need to find out whether it is a conservative field or a non-conservative field. We need to check. Okay, so we will calculate the matrix of it. So we'll calculate delta cross F. Okay, that is our I cap, j cap, k cap, I, j, k cap, and then we have dou by dou x, dou by dou y, and dou by dou z. Okay, and then in the x we'll have 2xy, then here we'll have x square plus 2y z cube, and then we'll have 3y square z square plus 2z. Okay, so we'll have I cap, and in the I cap we'll calculate dou by dou y of 3y square z square. See, this is a method of opening this matrix and writing down the determinant of that. So you will learn in mathematics. Okay, do not worry about that, like how I am able to write down this is a quite simple thing you must have done in the vectors as well. So if you have not done that, then okay, you can just learn it here, and then again in the mathematics you will again get it. Okay, so then you will have dou by dou x of 3y square z square plus 2z minus dou by dou z of 2xy, and then you will have plus k cap, then dou by dou x of x square plus 2y z cube, and then minus of dou by dou y of 2xy. So this is our complete expression. Okay, now let me calculate I component first, or the x-axis. So dou by dou y, whenever this is dou by dou y, whenever we do the partial differentiation, like for example I have dou by dou x of x square plus xy square plus z. Okay, let's see it. So here I will treat x to be variable. If there is y or z, I will treat them as constant. That is the rule to do the partial differentiation. So x square differentiation is 2x. Then I have xy square. So x differentiation is 1 and y square is constant, and z is constant and constant differentiation is 0. This is how we are going to differentiate this. Okay, this the same way we will differentiate here. Okay, so I have, look at here, we have 3y square z square. So the differentiation is going to be 6y z square. Okay, and 2z differentiation will become 0, and this side will have 2y x square differentiation will become 0, and 2y times of z cube differentiation is 3z square, so that becomes minus of 6y z square. Okay, so keep on checking whether I'm doing it correct or not. And d by dx, so here x, of course, here I have y and z, and here I have z, so it becomes basically constant, and constant differentiation is 0, and here also the differentiation will become 0, plus k cap, and then I will have this, the differentiation with respect to x of this term is 2x, and this becomes 0. So I will have 2x, and then here I have d by dy, and the 2y is a constant, and 2x is a constant, and y differentiation is 1, so again it becomes minus 2x. So if you simplify it, so then we'll have 0 I cap plus 0 j cap plus 0 k cap. Basically you get it to be 0, and if it is 0 it means this field is irrotational, and if this field is irrotational, so that's why it is conservative. Okay, it is a conservative field. So now see, I have this. If I look at this, I cannot say that just by looking that it is a conservative or non-conservative. I need to do some mathematics, then only I can say. Like for the gravitation, for the electrostatics, for the magnetic field, for the, like by the name we know that it is conservative or not. But if it is given mathematically, then you need to proceed mathematically to find it out. Think about it. Can there be any other method for this field to determine whether it is conservative or not? Think about it. If I just say that the f vector is given as 2xy I cap plus, what was that, x square plus, okay, what was that, x square plus 2y z cube j cap plus we have 3y square z square, so 3y square z square plus 2z k cap. I have like this, right? So yeah, if I just look at this, can we say by any other method, if this force vector is given to you, can you say that it is a conservative field or not? Think about it. Yes, there are the other definitions. What was the other definition? The work done in the, if it is conservative, then work done in all the paths will be equal. So what you can do is you can take 2 points and you can just calculate the work done. Work done is equals to f vector dot ds vector, and let's suppose if I'm going, okay, this is x, this x axis, y axis, and then there is z axis like this, and this is our origin 0 0 0. Let's suppose this is our initial point. You can take any initial point, okay? This is just, I'm doing a random calculation, and let's suppose we are going from here to a point 1 0. I'm just taking a plane in a point in the xy plane itself, okay? And now you move from this point, initial point, to this final point. So now if you want to move, there are different ways you can go. One way is you can go like this, okay, there is one way you can go like this, and then you can go like this, fine. Then another way is you can also go like this, and you can go like this, correct? And then there is another way like this. So basically in the first way, let's call it as path 1, you go from 0 0 0 to 1 0 0, and then you go like this. The other path is you go from 0 0 0 to 0 1 0, and then you go like this. This is the second path, and this is the third path. So these are 3 paths. If you calculate the work done, so of course you will you'll have the equations for this. The equation is y equals to 0, z equals to 0, and then you have this equation. The equation for this is, what is that equation? X equals to 1, z equals to 0. Okay, so if you substitute this and do the calculation, like this kind of question I have done. If you have doubts like how we will calculate this, so I have done some question. I will also attach that link of that video as well, so you can go through that, how we calculate in those cases if there is a force given like this and we need to calculate the work. If you do with that procedure, and if you get work done in the path 1 equals to work done in the path 2 equals to work done in the path 3, then also you can say that this is a conservative field. But this becomes a bit lengthy. So in these kind of questions, this calculation would be a nice method to find out, and of course like it will be a JEE Advanced question only. So I hope you must have understood this. Just I have talked about this conservative and non-conservative over here. If you want to know any other topic anywhere, like you have doubts, you can just comment and I will try to answer that. Thank you very much.